In this lecture, we will learn what is modal analysis and how to perform it in SAP 2000. Modal analysis is the study of dynamic properties of the structure. The primary modal analysis outputs includes structural time periods on corresponding the mode shapes. Each mode shapes corresponds to a specific time period. Modal analysis utilizes the structural mass and stiffness to compute the mentioned outputs. Therefore, it is important that you have applied at least the dead loads to the structure. What are the mode shapes and how it is time period related? As mentioned, each mode shape has its own specific time period. Consider a three-story frame as shown for demonstration purposes. Now, the mode shapes, the result of modal analysis performed on the two-dimensional structure would be three mode shapes and hence three corresponding time periods. The mode shapes corresponding to three modes are shown on the screen. Let's say mode 1 is the mode in which all the masses displaces in one direction. It has time period T1. The mode 2 in which two masses displace in same direction while the other mass displace in opposite direction. And the mode 3 having time period T3 shows alternative masses corresponding to different directions. Since it is a three-story structure and a two-dimensional structure, so each story has one mode. If it was a three-story structure, then we have three modes on each story. It is clear that T1 should be greater than T2 should be greater than T3, as in first mode all masses displace or rotate in same directions, hence higher displacement, and therefore time period would be higher. Similarly for second mode and so on. For three-dimensional structures, each story corresponds to three modes per story, considering displacement modes only. Modal analysis is also important to determine the mass participating in a particular mode, which we'll be discussing in this lecture. Most of the international codes such as IBC, ASC requires it to consider at least those modes in the analysis having mass participation of 90%. We'll also discuss this point in this lecture. Buildings with symmetrical shape, stiffness, mass distribution with vertical continuity and uniformity behavior fairly in predictable manner, a two-dimensional model is generally sufficient. Whereas when buildings are eccentric or have areas of discontinuity or irregularity, the behavior characteristics are very complex. For moderate to high-rise buildings, the effects of higher modes may be significant. For dynamic analysis, Ritz vectors are recommended over eigenvectors because the same number of modes. Ritz vectors provide better participation factor, which enables analysis to run faster with same level or even higher level of accuracy. Let's have a look on how to perform a modal analysis on SAP 2000. So I'll be utilizing this 40-story building which we have modeled in lecture number 22. For starting the modal analysis, go to define, go to load cases and click on add new load case if you haven't already added a modal load case. If you want to add a modal load case, you can click on here and select modal from here. But right now we have already a modal case defined in SAP 2000, any model by default. So go to modify. Here we have already shown that the selection is made for eigenvectors. We can also go for Ritz vector based on the criteria shown previously. For the number of modes as discussed already, since it is a 40-story building, so we need 3 modes per story. So this number should be 120 at least. And later we'll be checking whether this number is sufficient or no. And we can also leave the parameters as it is. You can modify the parameters if you want to based on the advancement of your analysis or research, and click on OK. Click on OK. Now perform the analysis by going to Analyze, Set Load Cases to Run. All the actions should be set to run. The dead load should be defined already. Click on Run Now. This is showing the details of the model analysis right now. The green color shows here that the analysis is not yet completed since it is a very high-rise building and the calculations are quite complex. In this later part of the lecture, I'll show you how you can increase the speed of analysis without affecting the accuracy of the results as per code recommendations. After the completion of running of the analysis, let's start with seeing the results. So right now we are in deform shape for dead load. Click on undeform shape. The first thing for the model analysis we are supposed to check is the time period. For that we have to go to show deform shape. Click on model. First let's see mode number 1. So mode number 1 is giving us a time period of 6.179 seconds. So the time period is the time required to complete one oscillation. So let's see in which direction the oscillation is. This one is y-axis, this one is x-axis. So click on start animation to see which direction we are getting the displacement is. As it is clear that the first mode is a displacement mode as we are getting the displacement of the building. But checking the animation will clear it further. So since the building is deforming in y direction, so the first mode is corresponding to y direction or the displacement in y. Let's see the mode number 2 and click on apply. If the first mode is in y direction, then the second mode supposedly for a regular structure should be in the perpendicular direction. So the second mode should be in x direction. As in the first mode we have all the masses displacing in y direction, and in second mode all the masses are should be displacing in x direction, but our second mode is rotation mode. As you can clearly see, the building is having a rotation mode. The rotation is about z-axis. This is our z-axis. And let's see the third mode. We have assigned 120 modes for this building. So let's see the animation for the third mode. The first mode is displacement in y direction. Second mode is rotation about z axis. And we are right now seeing the third mode is showing a mode of displacement in x direction, since all the masses and the floors are displacing in x direction. And we have a time period for the third mode as 3.46 seconds. What else we can see from this output is you can scale according to your requirements. You can draw contours on the object for displacement in x, y and z direction. That is all up to you. As well as you can also see the results of the cycling. If your analysis requires, you can also see the wire shadow. Wire shadow means that it would show us an undeformed shape shadow over the analysis. As well as I have checked the colored part or show contours on the object. That is the colored part. The blue color is deforming the least and this magenta color is deforming the maximum, which is obvious that the higher the structure away from the support, the more deformation will be occurring there. So this was because of the contours on the object due to ux, uy and uz. Since we are getting a displacement in x direction in third mode, so I selected ux. If I have to check this in y direction, so I'll be checking the mode 1, which I have cleared that it is in y direction. and you can click on contours on object and wire shadow as well. Wire shadow is this shadow we are getting for the undeformed structure, so that we can clearly compare in which direction the structure is deforming without even seeing the animated shape. You can see from here the wire shadow is this one. If I hide the wire shadow, then the undeformed structure would vanish. Now it is vanished, the gray part of the structure, and click on close. Now let's see the details of the modal analysis. For that, go to display, show tables, click on analysis result, structure output, modal information, and click on all of these and click on OK. Now the first is the load participation ratio, and it is showing the static participation percentages. So we are getting more percentage than 90%, so that is okay. You are now required to see the modal participation mass ratios, and this is one of the most important thing we have to see. From this table we can clearly see that in the first mode 81% participation is in y direction. In the second mode, that is mode number 2, we are getting in x direction very low, y direction very low, z direction very low, and we are getting the rotation about z direction as 84 percentage. You have to see this data in percentage. This all data is to be seen in percentage, this one as well as this one. These 6 rows are important to see to identify which number of mode is acting in which direction or which rotation. For instance, we saw that our first mode is in y direction, so it is clear that maximum displacement we are getting in first mode is giving us 81% mass participating in displacing the structure in first mode. In second mode we are getting 84% of the structure is participating in rotation about z-axis, and in third mode we are getting the 80% of the structure's mass is participating in x direction. So this all sum remains 1. However, it is important to identify if you want to increase the speed of analysis. As per code requirements, the maximum modal analysis sum or the participation ratio should be 90%. It can be higher, but for speed of analysis it should be at least 90%. So if we go to the sum part, we are getting, now we are supposed to see the sum. So these are my sum tables. So in sum table in x direction I am getting more than 90% on the 7th mode, while in y direction I am getting more than 90% in 4th mode, and in z direction I am getting more than 90% in so we have to see rotation about z. We are getting more than 90% at mode number 6. So for this kind of building, the sufficient number of modes for modal analysis will be governed by x direction, because some ux, some uy and some rz should be checked. But you can also include, if you are including the torsional analysis in the building, you can also consider the sum ry, sum rx to be at least 90%. So here if I consider this one, then we are getting more than 90% over here. You can ignore the sum u z because it is not coming out to be greater than 86%. So you can ignore this one because it is not really important to get the mode that incorporates the up and down movement of the structure, because in high-rise structure the lateral sway is what governs the movement of the structure. For instance, if I am supposed to consider for a conservative analysis, how many modes should I include in my analysis for faster analysis completion. So in UX, my sum is going above 90% at mode 7. In UY, my sum is going above 90% at mode 4. And in sum of RZ, my 90% above is going in mode number 5. So for conservative purposes, the highest mode I will consider be 7 mode. But if I include all of the all of the directions except UZ of displacement 1, then I'll be including some RY and some RZ, which is also coming out to be above 90% in mode number 20. So let's verify. In mode 20, the mass participation in X direction is 97. In mode 20, mass participation in Y direction is 100%. In UZ is 78%. We are ignoring the sum UZ. And the sum Rx is 96%, sum Ry 90%, sum Rz is 100%. So we are ignoring this one. Apart from this one, we are getting above 90% responses for all the displacement as well as rotations. And that is how, if you want to increase the speed of analysis, this is a tip that you can change it to 20 and then perform the model analysis and click on OK, and then you can run the model once again and see the results. That is how we perform model analysis in SAP 2000.